Hello, my name is Daniel Szeligowski, and I will be discussing a novel dataset and deep learning benchmark for classical music form recognition and analysis. This paper was done in collaboration with Lopamuja Mukherjee and Benjamin Whitcomb. And we also have a QR code for you that will take you to the GitHub repo that has all the original research, code, dataset, and supplement for this paper. Current analytical systems focus on popular music tests and forms, which are comparatively easy to those regarding classical music. Pre-existing datasets of phrase-analyzed classical music also feature numerous errors and lack standardized analytical conventions, and no such tool currently exists for automatic or computer-assisted classical form analysis, and translating this to an AI-usable format requires a double analysis of both the sheet music and a reliable audio file. So this has a wide variety of potential applications, such as audio, thumbnails, and fingerprints, which is something Facebook currently does, forensic musicology and copyright detection, data mining for musical anthologies, so compiling formally analyzed works, and music education and pedagogy tools, as well as numerous others. We have three primary goals for this paper, the first being to provide a new analytical model to perform full form analysis, so form classification, segmentation, and part/phrase labeling, and expand upon existing model architecture designs. We also develop a new standardized dataset, the Standardized Musical Form and Structure Analysis, or SMFSA database, by common analytical conventions, including categorical divisions by large musical form. And we present a more accurate deep learning model to perform both form level and part/phrase level analysis, and provide appropriate evaluation metrics and accurate model performance results. Our primary contributions for this paper include a system of three components: a form analyzer, peak picking algorithm, and phrase analyzer. We also use hybrid neural decision tree models to train quickly and reduce overfitting. And lastly, we provide a dataset built from 200 manually classified MIDIs, augmented with 5 different sets of permutations to expand the dataset to 1200. Here's an overview of our system architecture. We have the form analyzer model in the top left, which is the tree-grad architecture. Below that, we have a peak picking algorithm or onset detection model, both of which their output is provided to the phrase analyzer model, which is a bidirectional LSTM hooked up to a decision tree, which provides the final output. We have a few very promising results, the first being that the final form analyzer model achieved a maximum accuracy of 83.9%, and precision and recall were closely related to this score. This may also perform better as an ensemble model. As well, the peak picking algorithm proved comparable to other machine learning approaches such as CNN and self-organizing maps, as even pre-labeled data points were nearly identical to those marked by a human analyst. And on the right side, you can see what the final system output looks like, entirely generated by the final system. In comparison to other models, LSTM tree outperformed both individual neural networks, machine learning algorithms such as decision tree and random forest, and tree-grad, and using a hybrid neural network decision tree approach greatly reduced overfitting and thus increased accuracy for both form and phrase analyzers. We have a few suggestions for future work. The first being analytical extensions, so extending the system to allow for the classification of additional forms, such as those found in popular music and more complex hybrid forms. And in terms of optical music recognition, our methods could be potentially extended to perform visual music analysis and perform the segmentation/classification on the score itself. And forensic musicology, the system's output analysis might be useful in the comparison of multiple pieces of music for potentially similar or exact replications of musical phrases. For additional information, we encourage you to check out the paper and supplemental data for this work online. Thank you.